Hello. Today we are doing the completing the square proof. I said if we got 10 likes on my video about taking the square root of a matrix, I would do it, and we crushed that like goal, so here we are. So completing the square is often just taught as a process you should remember, and the quadratic formula is just taught as a formula to remember. And when trying to solve equations for their zeros, I don't like remembering equations, and methods, to an extent, I'm not a big fan of either. If I understand the reasoning behind a method, I can do it, and that's what I'm going to do today. And this was part of a question that I had to do for my last linear algebra test. And I used completing the square and not the quadratic formula, even though in class we were all told to do quadratic formula. We weren't allowed calculators, but now I'm going to show you the idea of completing the square. So, the idea of completing the square is you are literally completing a square. So we're going to have a couple of squares here. And so this first square is going to be to have an area x squared. Side length x. X times x is x squared. Next, we're going to have a rectangle with area 10x. So we can say this length is x, this length is 10. X times 10, 10x. Note that this length is the same as the length for x, because x is equal to x. Then I'm going to move this 16 to the other side, so negative 16. And this is just going to be some square. We don't really care about its dimensions. Some square, some rectangle. And yes, it's technically negative area, but we're not worrying about that. So now, what we're going to do is we want to turn this into a square. This side into a square. So this is just this area plus this area is equal to this area. And we want to figure out how to make a square, because squares are easier to just take the square root and solve for. So the way to do that is we can notice that if we cut this thing in half, then this section can go right over here. So you can imagine pulling this over here. Then we can imagine moving this section over here. So now this area is negative 10 over 2 times x. And this area is negative 10 over 2 times x. And if we added them back together, we still get negative 10x. So we're not changing anything here. But notice that we are kind of close to a square here, because this side length and this side length are the same. The only thing would be this square right here. So to literally complete the square, we add whatever this area. We can call it area A if we really wanted to. But what we do to one side of the equation, we have to do to the other. So we're going to say we add area A to the other side. We haven't changed anything. We're just looking at the picture slightly differently. So what is this area A to complete the square? Well, it is the area of the side length of the square times this one. So negative 10 by 2 squared. Negative 10 squared is 100. 2 squared is 4. So we're left with 100 over 4, or 25. So we were left with a thing that is squared now, right? X minus 10 by 2 squared because we have this times this. Okay, that's equal to negative 16 plus a, which we said was 25. So let's simplify this a little bit. Negative 16 plus 25 is 9. 10 by 2 is 5. So x minus 5 squared is equal to 9. We could do this a lot easier than something else. We take the square root of both sides, reverse of PEMDAS, square root. We say 3 is equal to x minus 5. This is going to be plus or minus 3, because we have to take the square root, include both solutions. So then we add 5. So x, the solutions are going to be 5 plus or minus 3. So 5 minus 3 is 2. 5 plus 3 is 8. So x is going to be 2 and 8. In my opinion, this is a lot more elegant than just shoving this into a formula, the quadratic formula. Here is me doing this from my linear algebra class. So we had to find the characteristic polynomial. We don't care about this. This is linear algebra jargon. But I was left with lambda squared minus 10 lambdas plus 16. So here's the factored version. But what I did first was I literally drew out the square and completed it. And so this was the first step I did. So, and I get the same answer, and I got it right on the exam. So, in my opinion, it's more elegant. All right, let's do another example, but where the first term, a, is not 1, to really show that this is a great strategy, especially if you don't have a calculator, like I did on my linear algebra exams. So first, we see that this first term is not 1. So we're going to make it 1. Let's divide everybody by 3. So multiply the entire equation by 1/3. We're now left with x squared plus 8 by 3 x plus 2 by 3 is equal to 0. Then we're going to move 2 by 3 to the other side. We're left with x squared plus 8. Nope, not 8/8. So we have x squared plus 8/3 x minus 2/3. Okay, same thing as before. We're going to create a square. Side lengths are x. The area is x squared. And then we're going to have this area over here, negative 2 by 3. And we want to complete this square. So we're going to draw this length of x, and this is going to be half. So this is going to be 8 by 3 by 2, which is 8/6. So then we need to add this area to both sides. This area is going to be 8/6 squared, which is going to be 16 over, let's see if I can do this in my head, 9. Does that simplify anymore? I don't think so. So now we add 16 over 9 to both sides. 16 by 9. So we're left with x plus 8 by 6 squared is equal to negative 2/3 plus 16 by 9. So let's simplify this a bit. 8/6 is just 4/3. 2/3, or negative 2/3 is just negative 6/9. Negative 6/9. So then we can add these two together, which is equal to positive 10/9. So then we're left with x plus 4/3 squared is equal to 10/9. Take the square root of both sides. plus or minus. So then we have x plus 4/3 is equal to plus or minus 10/9. We subtract 4/3 from both sides. So it's going to be negative 4/3. Because why not? We can simplify this even further. We can factor this square root as square root of 10 over square root 9, which is just 10 over 3, or square root 10 over 3. So then we have negative 4/3 plus or minus square root 10 over 3 is equal to x. But then we can put this in a recognizable quadratic form from the quadratic equation because these have the same denominator. We can say negative 4 plus or minus square root 10 over 3 which is what you would get if you simplified substituting all of this into the quadratic equation. In my opinion, it's more elegant than the quadratic equation. Yes, it probably takes longer, but it's more elegant and you don't need a calculator. And I don't know, I just like it more. But that's my opinion, you don't have to like it. So leave a comment what other interesting proofs or explanations you want me to do, or other videos. Subscribe. Goodbye.